उसको हम कैसे करके how we are using the mathematical tools so that prediction accuracy is better. So in that case, we are having different subcomputing tools now, because gone are the days when we are having a very simple ANN like regression based ANN, then radial basis function based ANN, and then we have come to the support vector machine, deep learning techniques. Deep learning, one of my students was at IRI, he worked on deep learning techniques to predict about the weather using the 35 years prior climatic data. So there we are using so many techniques. And what I feel personally nowadays, we are just going by the software. We don't know what is happening inside. That was a problem with me when I started, but I tried to learn what is happening. If we know how the software is calculating that, what equation is taking, how the bias is estimated, and how we can have the training and testing, both parallel things at a place, so that our prediction will be better. That means if we validate with the data. So I developed in the beginning of my career the the data partitioning technique. Suppose we are generated 100 data from the experiment. How much of the data we can partition as a testing and training? Because in any subcomputing tool, in AI or ML, machine learning languages, the two activities run parallel, testing and training. And then there is an unforeseen data, because sometimes computer is so intelligent, if they can see the data, they will have their inner architecture in the similar manner. Because that ANN is, what is ANN? Is the cognitive response of the human brain. हमारा brain में what is the neurons are there, axons are there, how they are coordinating. So how that can be just that if a simple ant is biting us, then suddenly that information goes to your brain. That brain tells your hand to pick up the ant. So that type of complicated, very conspicuous, very complicated. It is not that easy. And if you can say that I have developed a deep learning algorithm, then we can see that most of the things are from USA universities or big universities. They are the brainchild behind coding and programming. But recently one of my students has coded some thing in Python. In Python they have tried to coded that how the input-output mapping can be done. So with this background information about that, because I understand that you may be knowing much more than me, but whatever work we have done. So before we start, because I am from Water Management Institute, so water management is not a very new activity. If you look into our ancient mythologies like our Mahabharata and Purana, the Arjuna, and they also talked about water, rejuvenating water bodies. Now our Honorable Prime Minister is telling that you rejuvenate water bodies. It is a spiritual activity more than science activity. And most of the water productivity we are getting from these regions is through renovation of the water harvesting structures. So and also that land, water and vegetation, these three are very important activities for sustainable development of a country. What is sustainability? Sustainability means we have to meet our own need without compromising the ability of the future generations to meet their need. इसका मतलब है हम अभी जो भी काम कर रहे हैं, जैसे एग्रीकल्चर कर रहे हैं, उसमें हम हर्बिसाइड अप्लाई कर रहे हैं, how to kill the weeds on wanted plants, पेस्टिसाइड अप्लाई कर रहे हैं to kill the insect and pest. उसमें क्या होता है? If you are not adopting a proper protocol, you are applying more herbicides, more pesticides. The excess amount of that is migrating to the groundwater and polluting that. ये बहुत सारा issues हो रहा है in the northern India, in Indo-Gangetic plain, due to indiscriminate use of the fertilizers, herbicides and pesticides. The natural resources are at stake. So then why the sustainability is coming into picture? The country where you can see that their land resources are very good, their population also under control, and they are managing the natural resources judiciously, that country is progressing. So, if you look into North America and other countries, they are having the population density very less, maybe 3 to 4 persons per square kilometer. But if you look into India, our census status is 1,500, 2,000 persons per square kilometer. ये तो है, लेकिन ज़्यादा लोग भी होंगे. So इसी हिसाब से हमको and you know that the sum total of water in the universe is constant. Water can neither be created nor can be destroyed. दो हाइड्रोजन मॉलिक्यूल, एक ऑक्सीजन मॉलिक्यूल से वाटर निकालना बहुत मुश्किल है. हम लाभ में तो कर सकते हैं, but not in wider scale. And you look into other countries like Israel, those are having very deficient water resources. They are using the saline water to do the technology, and they are using irrigation, and they are using micro irrigation and other techniques. And but the main concept is everything is the sorry. आगे जा रहा है, पीछे आगे एक ही जा रहा है. Can I go back? That reverse mode is not working. Okay. Yeah. Okay, I can do that. Yeah. So the hydrology cycle plays an important role. How much rainfall is occurring, how that is being intercepted by the plant, how much is evaporated to the soil and joining the aquifer. Again, that is getting evaporated, forming the clouds, and then rainfall. This is a continuous process. So the sum total of these activities taking place in a regional scale is constant. Now the question comes: how we can account for this variability? There is variability under the spatial and temporal domain. Due to changing climate, you must have seen that many areas, like Bundelkhand areas, which are having highly sufficient rainfall 1 decade before, now there is a lot of stress on the rainfall. In Maharashtra, some regions, in Odisha, some regions are coming to that. There is a spatial and temporal variability. Some areas are getting very high intense rainfall and low duration, because you know intensity and duration of the rainfall are inversely proportional. अगर intensity बढ़ जाएगा, duration कम होगा. So these are the aberrations we are getting in many of the things. And these are the in our country the main issue is the population growth. If you add the per capita water availability, we are not going to be at a comfort level in future. आराम से रहने के लिए कि आदमी को कितना पानी चाहिए? 1400 लीटर पर पर्सन, 1400 मीटर क्यूब पर पर्सन पर ईयर चाहिए. लेकिन हमको अभी देखा जाए तो बहुत कम, कुछ जगह तो बहुत कम मिल रहा है. And also the land resources, they are also depleting. Many people are converting that forest area to their habitation. Population बढ़ रहा है तो क्या करेंगे? We can have big buildings, some infrastructure coming. So the main issue, what I am telling is the anthropogenic interventions. Anthropogenic means man-made. यहाँ पे पहले 10 साल पहले, आपका 15 साल पहले, 20 साल पहले इंस्टीट्यूट नहीं था, तो उसका जो नेचुरल ड्रेनेज नेटवर्क अलग था. पानी rainfall was occurring, that is flying to the natural path and then going to the river and sea. But we are the people, we have due to our requirement, we have come up with the infrastructure which is diverting or disturbing rather our natural ecosystem. So then the time came to use the modern tools. Gone are the days when you are using very simple spreadsheet. हमारे टाइम पे तो वो स्प्रेडशीट भी नहीं था, हमने जब PhD किए थे. क्या था उस टाइम में? Do you remember? आपको तो पता नहीं होगा. So but at that time also at IIT Kharagpur we are using the punch cards to use in a computer. 486, 386 computer हमने काम किए. But then subsequently so much now we are having everything in the mobile app. So gone are the days. Now that's why now we are having Python programming. Python programming is a programming which is compatible with every system. That is very robust. You can go for mobile application, you can go for decision support system, you can go for desktop based programming, anything you can do. Okay, and that is also a component object model. Component object model means anything which is compliant with other systems, that is called a component object model. So and also we are having the geographic information system, like, but GIS is a very old tool. We were doing at that time ESRI का पहले जो ArcGIS version था, that is a lower version. We are using big digitizer boards, you know, to having a digitizer mouse, then connect that to the computer, move the mouse, put the map, and do digitization. But now we can do it on-screen digitization. But nowadays on-screen digitization is not required. Simply you give a command, put the map in the background, automatically that can trace the road network, then the polygon pictures and the point. क्योंकि दुनिया में तीन चीज में होता है, three attributes can define any activity you are doing. What is that? Point, line, and polygon. तो थोड़ा सा मैं टीचर था इसलिए मेरी फंडामेंटल पढ़ा रहा हूँ. But if you know just that point is having existence, no extension, line joining two points, polygon starting point, ending point से. आप दुनिया में कोई भी चीज बताइए जो कि तीन में नहीं है. चाहे लेक है, लेक पॉलीगन है. ये मकान है, मकान पॉलीगन हो सकता है, पॉइंट भी हो सकता है. मैं इधर खड़ा हूँ, मैं एक पॉइंट पिक्चर क्लास हूँ. एक ट्यूबवेल है, ट्यूबवेल हम खुदाई करते हैं, दैट इज आल्सो पॉइंट पिक्चर क्लास. रिवर इज अ लाइन पिक्चर क्लास. रिवर कैन बी अ पॉलीगन पिक्चर क्लास. अगर हम बफर जोन करते हैं उसके चारों तरफ, what is the buffer areas where the flooding zones are there, then we can delineate that area. There is the flooding zone in the periphery of the river. So GIS made our job easier, because ESRI President Professor Dangarmod. There is nothing which cannot be done by DSS. Anything we think by GIS, anything we think we can do it. That is the tagline was, what is the tagline? Better information leads to better decision. Better information leads to better decision. That means if I am well informed, I have to come from Chandrasekhar IIWM to that IIIT in here. So then I have the Google map. I know that when I have to start, how much time it will take, I can reach and take my class. So these systems are now much advanced. We are having all gadgets, sensors, then our satellite informations, linking the sensors with the satellite locations and GPS enabled devices, making our things very easier. And then, but the main thing what we feel in our GIS and geospatial data analysis, what is geospatial data analysis? It is combining GIS, remote sensing, GPS, which can capture the spatial and temporal, spatio-temporal variability. So we can do anything with that, but the ground truthing is very important. Without ground truthing, we cannot. Then the पहले वाला gig हो जाएगा, garbage in garbage out. So what I advise, what I request you from my experience, that whatever data analysis we have done, whatever the case studies you have done, we have corroborated that through ground truthing. Ground truthing is very much important. Maybe we are deleting a canal network, so we have to see that with that GPS you have to go to the area and see whether that we are preparing a point attribute table of the groundwater tube well locations. So we have to go to that location and see whether the existing tube well is not there. Or as per the Government of India's Amrit Sarovar scheme to identify the water harvesting structures of farm ponds, ओडिया में बोलते हैं क्या पोखरी. So we have to find out. You take a GPS and find out the exact location of that. That is called the ground truthing. वो बहुत जरूरी है. And so we started our work in many activities. So I will be highlighting some of the works which I could able to capture from my previous slides. So that we started our work on finding the low productivity zones in the Western Jamuna Canal Command. So for that we prepared like the groundwater quality map, salt affected soil map. We use all the geospatial data analysis mapping, and also we use the geostatistics, because I will tell you one thing. There are two methods of interpolation. I think many of the faculties must have taught about this thing. One is deterministic statistics, other is geostatistics. In deterministic statistics, we go by only mathematics. कि ये 50 मीटर का कंटूर है, ये 70 मीटर का कंटूर है, 60 मीटर कंटूर कहाँ जाएगा? Just to use mathematics. But the best one which I have feel in my 28 years career, which I did, first I started working on geostatistics when I was a postdoc at McGill University, Canada. There we took the data of the Saint Lucia in the Caribbean. There we collected the rainfall of 40 different locations, and we tried with deterministic statistics, but the prediction was not good. Then we went for the geostatistics. Geostatistics is based on the premise that all the points on the earth are not disjoint, they are related to each other. Every point on the earth are related to each other. But we have to explore that mathematical relation. For example, I am standing here and you are sitting there. We are related to each other. Maybe I am an invited expert delivering a lecture and you are the participant. But that is not a mathematical presentation. I am at a given elevation and you are at a given elevation. There we are having some quantifiable measures. Then we can have a semi-variogram relationship. Then we have to fit the semi-variogram using Basel equation or power equation or any other empirical equations. We have to link that. Then using that equations, we will be predicting what is happening in the other areas. You will put in that input as the latitude and longitude. So the geostatistics is a combination of mathematics and the probability. So the combination of mathematics and probability give you a better representation. So all these maps, these are not done using the deterministic statistics. We have used the geostatistics. And one limitation is that. What is the limitation in geostatistics? You should have at least 10 points, minimum 10 points. उससे कम होगा तो आपका वो सॉफ्टवेयर अच्छा काम नहीं करेगा, accuracy नहीं आएगा. So you should have minimum 10 points to have the spatial variability mapping. So So we did the mapping of all the thematic layers. Then GIS में बहुत ही अच्छा चीज होता है, that is called geo processing operation. Geo processing क्या होता है? What is that geo processing? Overlaying, union, disjoint. So एक के ऊपर एक हम रख देंगे तो हमको बता देगा कि ये एरिया जो है that is highly salt affected area. This is the area where if you go for agriculture, that area will not be good for agriculture. So we can delineate the areas which are not good for one activity. I remember that the days of working in a Saint Ispi watershed, which is in Canada. There the farmers are facing the migration of the phosphorus load to their water bodies. You know, the more application of the phosphorus and nitrogen in the agricultural field can lead to eutrophication. यूट्रोफिकेशन वजह से क्या होगा, अगर कोई एनिमल वो पानी कंज्यूम करता है और कोई अगर ह्यूमन भी कंज्यूम करता है तो दे हैव ए ब्लू आइड बेबी सिंड्रोम, उनका किडनी लिवर सब धीरे धीरे खराब होने लगता है. सो देन व्हाट वी डिड ए मैपिंग ऑफ द एंटायर एरिया, collected the samples from different locations, did the geostatistics, then identified that which areas are contributing more. Then me and my professor went to the farmer because their beneficiaries are very nicely mapped. इंडिया में भी आजकल हो रहा है, but there if the farmer is having 2 hectare 3 hectare area, that beneficial list is available. So we met the farmer and we told them that don't apply more peak. They are using peak down. From the peak down, the phosphorus migration was very high. So what we did the research for 1 and 2 years. Then we went to the stakeholder and we discussed with him. We deleted that regions. ये area में that farmer in the particular field is applying more peak down. Then we convinced him. Then the farmer is very educated. They got convinced, and then they started applying low dose of the peak down. And आप देखेंगे after 1 year we could be able to see the miracle that we could able to collect the samples, water samples from the water bodies, and then measured using the LS3 method. The phosphorus concentration was very less. So this should be the research. Nowadays, Government of India is telling that whatever you do, okay, we are doing subcomputing tools, very advanced particle swamp algorithm, support vector machine, deep learning, rocket science में भी यूज होता है. बहुत एडवांस नॉलेज है ये. हम मानते हैं कि ये some parts are used in our moon mission also in the rocket science, but still in our field in agriculture, because I can tell only about agriculture because I am an agriculture scientist. I have been in the agriculture. I was at IIIT for 28 years. So we are at the Premier Institute of Agriculture. So we are being told the whatever work you are doing, do for the agriculture. So if we do something science is very good, but we have to corroborate that with the reality. So इसके लिए what my request is that whatever you are thinking, planning, that's very good. You are having very advanced knowledge in data analysis, but how that analyzed result will be useful for the beneficiaries, for the stakeholders. Stakeholder only farmer नहीं है. Farmer के साथ academician भी stakeholder है, student भी हमारा stakeholder है. For example, I have developed decision support system. I'll be coming to that. To select that what are the different soil and water conservation structures, हम उसको कहाँ लगाएं, कहाँ करें कि हमारा मिट्टी और पानी का बचत होगा. So that I developed using pattern programming, and I am teaching to that to school students. They are also very happy, sir. What are the different structures they can know? उनको नाम, they can know the name. What are the different vegetative measures? What are the different soil and water conservation measures? So that they can also use that technique. So these are the different techniques I want to. Then we use the protocol, very simple protocol. If then else programming construct उसको बोलते हैं. If this is this, then what? Else what? If then else. उसमें सब कुछ समाहित है. Everything आप if then else करोगे ना, बहुत सारे काम कर लो. If then else. And then we use some of the indices like normalized difference vegetation index, normalized difference water stress index, normalized difference salinity index. Then using these indices, we could able to delineate that area. Yes, that is the area. These are the areas we could able to get that. These are the areas of low productivity. उसके बाद हमने stop नहीं किया हमारे research को. We didn't stop our research there. What we did? We took the latitude longitude of that area from the software, then went to that area and see what is happening there. And really it was there, and the farmers are not getting good. There are white patches of the salt are there. Then we started our technology. हमारा क्या technology है? जो किसान they are affected by the salt affected area. What is the technology? The technology is go for surface washing, use the soft surface drainage technology, use the salt tolerant cultivars, राइस में भी कुछ कल्टीवर है, जैसे हमारे उड़ीसा में लुड़ीश्री है, लुड़ीश्री बहुत चलता है कोस्टल एरिया में, उसी एरिया के लिए उनका हमारे आईसीआर का इंस्टीट्यूट है, सीएसआर एक्सटर्नल सेंट्रल सैलेंट रिसर्च इंस्टीट्यूट, उनका बहुत अच्छा से कल्टीवर है. We advocated to the farmers that you go for these techniques, you go for surface drainage system to leach out the excess salt, use the surface washing mechanism, use the salt tolerant cultivars. Then उनका अच्छा हुआ. They were very happy कि हमने कुछ कर दिया. So what we did here, we did lot of science, we collected the remote sensing data, we did all the tools, we calculated all the indices, we did so much calculations, but finally the output is that should be delivered to the stakeholder. And then actually in agriculture, the main thing is the evapotranspiration in the water budgeting. Water budgeting का मतलब क्या है? Every day we are doing budgeting. Budgeting नहीं करना हम इधर नहीं होते. Budgeting is the basic hypothesis of research you do. What is that? Input minus output is equal to change in storage. आप कहीं भी लगा दीजिए. आपको कितना तनख्वाह मिल रहा है, कितना पॉलिसी मिल रहा है, क्या मिल रहा है, आप कितना खर्च करोगे तो कितना बचेगा, so that your life will be very comfortable. In the water source also कितना rainfall हो रहा है, how much rainfall we are receiving, how much is passing through the porous media, going through the groundwater, how much is available we can store, and what are the crops we can take in the peripheries, so that we can enhance the water productivity. That is through the water budgeting. अगर water budgeting हम नहीं करेंगे तो कुछ नहीं कर पाएंगे. So in that case, we use this remote sensing and GIS tool to do, because remote sensing का benefit क्या होता है? हम देखिए हमारे रिसर्च इंस्टीट्यूट में हम क्या करते हैं, फील्ड एक्सपेरिमेंट करते हैं, छोटे छोटे प्लॉट लेते हैं, एक हेक्टेयर का छोटा सा प्लॉट लेते हैं, अलग अलग ट्रीटमेंट डालते हैं, एक में फील्ड कैपेसिटी इरिगेशन करते हैं, थोड़ा सा 20% कम करते हैं, देखते हैं. बट इन रिमोट सेंसिंग यू कैन टेक द एंटायर कंट्री एज ए होल. यू कैन टेक ओडिशा, you can take Bhubaneswar also, you can take small district, Puri district also. ये हमारा एक बहुत अच्छा है, but think again the ground truthing will come into picture. So we can do many things using remote sensing and GIS, but this is your imagination, that is your innovation, your out of box thinking. उसमें हम कुछ भी कर सकते हैं. So many of my students they had what, and I will be coming very briefly to them so that you can have some brainstorming कि हम क्या कर सकते हैं, so that we can discuss further. So this is also one activity. This is also one activity. We could able to estimate the actual evapotranspiration. What is evapotranspiration? Evaporation from the bare soil surface. Evapotranspiration, transpiration from the plant. Transpiration क्या होता है? The amount of water transpired by the plant to prepare the food for their growth. And then another is that amount of water retained by the plant tissues for their metabolic activities. कुछ तो उनका साफ फ्लो में रहता है, लेकिन that is very less. That is only 1%. So evapotranspiration is a major percentage of the water being consumed. So if you are having rice crop, you are having maize crop, you are having any other crop, there will be actual evapotranspiration. But for evapotranspiration, it is zero. That is called reference evapotranspiration. उसके लिए दुनिया में बहुत सारे मॉडल हैं. आपका जो रिमोट सेंसिंग में आपको पता होगा, जो यूनिवर्सिटी ऑफ वाशिंगटन डीसी में प्रोफेसर आलन है, they have developed one e-flux, metric e-flux. आप गूगल में सर्च करेंगे, metric e-flux is a product. There you can get the actual evapotranspiration area. आप भुवनेश्वर का इस एरिया में भी जंगल में भी देख सकते हैं कि कितना evapotranspiration हो रहा है. So the metric e-flux, मेरा स्टूडेंट ने भी उसमें PhD किया है, how to use that metric e-flux. They are using the algorithm. What is the algorithm they are using? Do you know what is SEBA? Surface Energy Balance Algorithm. That is what is the incoming radiation, what is the outgoing radiation. That radiation will be giving you the actual evapotranspiration. So what I mean to say is that in actual evapotranspiration using remote sensing you can get the actual. If not actual, you can get all the calamity parameter, get the reference evapotranspiration, multiply the reference evapotranspiration to crop coefficient, then you will get the 80. Crop coefficient अलग अलग होता है. आपका लाइसेमीटर होता है, लाइसेमीटर में आपको अगर मेजर करेंगे उसमें आपको कैसे मिल जाएगा, नहीं तो एफएओ का कैसी वैल्यूज है, एफएओ का जो वेबसाइट है उसमें कैसी वैल्यूज है, राइस के लिए है, मेज के लिए, व्हीट के, ऑल क्रॉप्स के लिए. You multiply ET0 calamity parameters निकाल सकते हैं. There are many tools are there. Multiply that ET0 in casing, you will get the 80. So, but that's why the actual evapotranspiration is very important. That can tell you what is water budgeting. कितना बारिश हुआ, प्लांट ने कितना पानी लिया, कितना पानी नीचे चला गया, और कितना पानी अवेलेबल है हमारे पास. So that we can go for optimal water allocation, right? Any questions so far? Is it interesting or it is you know it is OHT? Sometimes क्या होता है ना, OHT क्या होता है पता है? OHT overhead transmission. लग रहा है नहीं तो मैं अलग अलग मोड पे जाऊंगा. ओके ओके जीरो. अच्छा अच्छा ओके good. Then here also we are using in the what is happening in northern India. They are going for the basmati rice cultivation. Due to rice cultivation they are drafting more groundwater. तो हमारा एक स्टडी था सेंट्रल पंजाब में कि how we can use the remote sensing and GIS and modeling to come up with the protocol to know that how much groundwater draft they are doing under the given area of cultivation. उसके लिए हमने क्या किया? We use the remote sensing data like Sentinel data, Landsat data with list 3 and list 5 sensors, and then we use the SWOT model, and then the mod flow model. Mod flow model can tell you about the simulation to the groundwater, and then we combine all these things, and then we integrated that with climate change model under RCP scenarios. Representative carbon pathways. उसका 3 है ना, 2.5, 4.5, 8.5 scenarios are there. Under the different RCP scenarios, we projected कि 10 साल के बाद क्या होगा, 20 साल के बाद क्या होगा. Then we developed the protocol. These are the different to do that. These are the different phase diagram. Oh, there are some. Whenever you are using a model, you know because you are all expert, you have to use some input data for that. So input data के लिए हमको पूरा system का जो control volume है जिसमें हम काम कर रहे हैं उसको हमको डाटा चाहिए पूरा. जैसे फेस डायग्राम चाहिए कि उसमें कौन सा लेयर है, उसका बासाल्ट है, सिल्ट है, क्या है, एंड लोकेशन मैप, ट्यूबवेल कितना ट्यूबवेल है, दैट इज प्रिपेयर्ड. आई आल्सो एंड आल्सो द कैनल्स, कैनल कमांड में कहां कैनल पास कर रहा है, क्योंकि कैनल में सीपेज ही हो रहा है. व्हेनेवर वी आर रनिंग वाटर इन द कैनल, दैट इज आल्सो सीपेजिंग. चाहे लैटरल सीपेज हो, चाहे वर्टिकल सीपेज हो, सीपेज तो हो रहा है, दैट इज आल्सो कंट्रीब्यूटिंग. तो ऑल द थिंग्स वी अकाउंटेड, एंड देन we could and then we then prepared a grid layer, superimposed all the layers in the grid, and then we went for the finite element modeling using the IJ. वो तो अंदर करता है, लेकिन हमको समझना पड़ेगा what is the numerical method of solution, what is finite difference and what is finite element techniques. वो भी हमने अप्लाई किए थे वो प्रोजेक्ट में. Then we could able to come up the then calibration. You know, calibration of a model is very much required. If you are not developing a model, if the model is developed somewhere else, that need to be calibrated using the data of your experimental side. After calibration, the job is not over. You have to go for validation, model validation. तो हमने calibrate किए, validate किए. जब validation में आपका जो prediction error statistics होता है, लोग बहुत करते हैं. कोई R square करता है, R square तो Gaussian determination, then residual sum square, और आपका P bias, बहुत सारे पैरामीटर हैं, और degree of agreement, मॉडल एफिशिएंसी आपको पता होगा. तो बहुत सारे करने के बाद हमने देखे कि यस विद दिस सिनेरियोस द मॉडल इज वर्किंग गुड, एंड देन वी कुड एबल टू अप्लाई दैट. एंड आल्सो अंडर द क्लाइमेट चेंज इनिशिएटिव वी कुड एबल टू आइडेंटिफाई द डिफरेंट वेल्स एंड व्हाट इज द which one will be called as a deep tube and which one is a medium, and then we delimited the areas where the groundwater extraction is very high. Based on that we change our cropping scenarios. And also another thing we did using remote sensing GIS for the, and what happens in the coastal areas due to the tide and in the sea pressures of the sea, then there is sea water intrusion. Sea water intrusion और sea पानी का जो नमक वाला पानी है वो आके हमारा अच्छा वाला आक्यूपर में मिल जाता है. That is also a serious case in many, and in Netherlands also this is very severe. So they are having pumps running throughout the day. अगर एक पंप खराब हो जाएगा तो Netherlands पानी में डूब जाएगा. So with that we also applied that for our Puri region, and then what we did using some model, we could able to come up with a protocol that what should be the optimum pumping schedule from the pump or from the tubewells. हम कितना पंप करेंगे, कब पंप करेंगे, कितना पानी पंप करेंगे जो कि sea water intrusion नहीं होगा. So that type of things also we developed, and then there is a change in the impact of the land use land cover. Land use land cover change क्यों होता है? Due to anthropogenic interventions, man-made interventions. I told you that man-made interventions are causing a lot of issues in our country and also abroad also. That is also giving rise to our greenhouse gas emission and causing climate change. And carbon credit का भी जो है green ecosystem को नहीं करता है. So we have to look into that. For example, if a farmer is operating a tube well, जैसे उसको 4 सेंटीमीटर का पानी चाहिए 1 हेक्टेयर एरिया में, उसका अराउंड 40,000 लीटर हो गया. उसका डिस्चार्ज अगर 10 लीटर पर सेकंड है, वो 8 घंटा 9 घंटा चलाता रहता है. जो कि 4 सेंटीमीटर रिक्वायरमेंट है उसको 20 सेंटीमीटर जाता है पानी। तो उसमें क्या प्रॉब्लम है, आप ही इज अप्लाइंग मोर वाटर। नॉट ओनली दैट, कार्बन क्रेडिट का जो बेनिफिट मिलना चाहिए इंडिया को वो नहीं मिल रहा है, क्योंकि वो डीजल पंप यूज कर रहा है, उसमें कार्बन ये होता है, दैट इज नॉट ओनली कार्बन, दैट इज कॉजिंग द क्लाइमेट चेंज। हमारा द प्रॉब्लम वी आर फेसिंग इज ड्यू टू आवर इग्नोरेंस ओनली। It is not that for our comfort level we are using refrigerators, good quality cars and everything, but due to our improper water management that is leading to the greenhouse gas emission causing the climate change. तो उसको भी हम estimate कर सकते हैं using all these techniques. And then the pollution also, we are also working on groundwater pollution, that in abroad there is a concept of TMDL, total maximum daily load. कोई भी फार्मर खेती करता है, उनका एक जो पानी जाता है रिवर को, वहाँ पे एक गेजिंग स्टेशन है, there they have the provision to measure, to collect the sample and estimate what is the level of the concentration of the nitrogen, nitrate nitrogen, ammonical nitrogen, what is the concentration of phosphorus, what is the concentration of potassium, what is the concentration of the herbicide they are applying, what is the concentration of artisan pesticide they are applying, जो बहुत dangerous है. If you look into that Punjab region, you might have heard in the newspaper in that Kapurthala and other areas like your Matinda and some areas, there are a lot of cancer incidents are there, and daily one train is going from that area to Delhi for the cancer patients. So that means we are the creator of these problems. So we have to ensure that we have to apply the doses of the fertilizer and the herbicide in a very safe limit. Then only we can eradicate this problem. So these studies also you can do using the remote sensing data and the modeling approaches. And then these are some of the, gone are the days then we have to go for step-by-step procedures. So built-in macro concept came into picture. So in the built-in macro, what is built-in macro? What is a macro? So many steps if you can do with a single click of the mouse, that is called a macro. So we have developed some of the interfaces using the built-in macro visual basic application in the GIS. So to make our process automated process. So that also many systems are developed to estimate the geomorphological parameters of the watershed. That can give us the how much runoff will be generated, how much sediment will be generated from the watershed. So they are also available. And then the decision support systems. Now you know what is decision support system? That means suppose we want to select the best candidate, उसके लिए हमको उसका बहुत फाइल देखना पड़ेगा, best faculty. So you have to look into what is the publication he has done, how many hours he has taken, what is the score he has in the BTech MTech career. उसके लिए हमको बहुत चीज देखना पड़ेगा. In the decision support system, if we put all the things in the background, then if you write if then else, in the click of the mouse, we can find out who is the best faculty. So this is just a very simple language I am telling you, but it is not that simple. We have to have a background, very huge database in the background. Then only in my career I have developed around 4 decision support systems. In the last decade it was 2, before that decade it was 2. So, and also these are some of the things I mentioned. Yeah, this is the thing I was telling you, that is the metric efflux. This is the product which is available open source, and this you can utilize to know the actual evapotranspiration. If you can go to the Google, write metric efflux, you can get the link. You can try about the areas, you can delineate in the nearby areas of the IIIT campus, how many trees are there, or how many trees it cannot tell, but what is the actual evapotranspiration in the area, that can give you. Right, then also we have used that in the surface runoff estimation. If there is rainfall in the area, how much runoff will be generated? Why we are quantifying that? That means that runoff we can store in a water harvesting structure or from the rooftop water harvesting. Then we can plan कि इसी area से इतना हमको runoff मिला, and how we can utilize the runoff in our different activities. Maybe we can use that for our household activities or grow different crops and enhance our livelihood of the different farmers. And then we have used different models like SWOT, knowledge, agriculture, non-consensus policy. These are the different hierarchical models we have developed. And one more thing, this very interesting thing which I did in around 2017 and 18 with one of my students from Iran. We did one analysis to grow the maize crop in the field, collect all the data, do the crop modeling to predict the yield. Then we integrated that with the climate change. Then we told that if we will be going to cultivate maize in 2024 or 25 or 2030, then how much irrigation water we can give, then what will be the yield scenario. So that means by integrating the climate change models with the crop model, we can come up with the prediction in the future कि अगर हमको rice लेना है, maize लेना है, ground लेना है, तो आपको कितना पानी देना पड़ेगा और कौन सा कल्टीवेटर लगाना पड़ेगा, उसका यील्ड कितना होगा. So that is on one, and this was published in a very good journal. So this is the work we did, but this is not, this is a 3 years work, but I am telling you within 2-3 minutes. So yeah. So another of my student worked on the hydrous modeling to link that what will be the scenario for download use in the, he integrated the hydrous model, then the mod flow model for the movement of water in the Bhados zone, and joining the aquifer, and then link that with the climate change model to tell that if you are using such type of pumping from the tube well, कितना दिन तक वो ट्यूबवेल काम करेगा. अगर देगा तो 2030 में कितना पानी देगा ट्यूबवेल, अगर वो इतना पानी देता है तो हम क्या क्या क्रॉप कर सकते हैं. So these are the things we can do using the climate change. These are the different scenario we generated. Yeah, these are the scenarios. Scenario 1, scenario 2, scenario 3. अगर टेम्परेचर इतना इंक्रीज हुआ क्या होगा, टेम्परेचर अगर ज्यादा इंक्रीज हुआ क्या होगा, बिजनेस एज यूजुअल सिनेरियो अगर होगा, तो दिस इज जस्ट एक बार once you have already calibrated validated model or the integrated modeling. Here I am talking about not a simple model. It is called integrated modeling framework. So gone are the days when we scientists are working in a room and publishing papers. उसमें कोई फायदा नहीं हुआ. हमने और गवर्नमेंट ने बहुत साल देख लिया. Now this is the time we have to integrate. I should not sit at IIWM as a director. I should integrate with other universities to see that what you people are doing, and then we can have a very focused approach and say that yes, if we can link all these things, then we can come up with these scenarios. तो अभी दुनिया हो गया इंटीग्रेशन का, नेटवर्किंग का. तो उसमें हम जो आउटपुट लेंगे, that will be benefit for the stakeholder. That is my personal feeling. I don't know how far you will accept it or not. And then whatever fluctuations we studied, and the artificial intelligence the algorithm or machine learning can be used in different activities in the agriculture sector, like your surface runoff estimation, crop yield estimation, irrigation scheduling. Irrigation scheduling का meaning क्या होगा? 3 क्वेश्चन है irrigation scheduling में. How to apply, when to apply, how much to apply. और एक क्वेश्चन में ऐड हो गया, what quality of water to apply. तो हमको कब पानी देना है, कितना पानी देना है, कैसे पानी देना है, और कौन सा क्वालिटी का पानी देना है. तो these are the things we have to do in irrigation scheduling. वो भी हम कर सकते हैं. And there are some of the public, वो जो पहले बता रहा था, first publication I did when at McGill University, Montreal, Canada, to predict from the in Hazaribagh one what set was there. We used the data, used the artificial neural network, went for the Redel basic algorithm, GRSS, and also different permutation combination we tried. The hidden layers, number of hidden layers, the number of the nodes, how to have a bias, how much data we can keep for the testing training. So we could able to come up with this publication. This publication is available, and also then there are three aspects of the AI used in agriculture. One is a very empirical model. Empirical means black box. Black box क्या होता है कि आपके पास ओनली आउटलेट में एक डाटा होता है, डाटा को आपने एक रिग्रेशन इक्वेशन पे करते हैं, ब्लैक बॉक्स मॉडल. अगर उसी एरिया में कोई नया लैंड यूज हो गया, कोई नया बिल्डिंग हो गया, तो वो इक्वेशन काम नहीं करेगा, बिकॉज दैट इज नॉट मैचिंग विद द रियलिटी. रियलिटी में एक अलग चेंज होगा. Then we are having a conceptual model. Then we are having a process-based model. Process-based model में we are using physics, laws of physics. We are using good equations. And then the fourth one is a hybrid model, because we cannot go for a simply empirical model. Maybe that is not the black box model. Then if you want to use more data, there will be very data intensive. आपको बहुत time लगेगा. Then the scientific community switched over to the hybrid model, and they could able to see that the hybrid models are giving better accuracy. So these are some of the areas. On the drainage also, in agriculture field drainage also, we applied the neural network and to find out that what type of drainage activity we can do, so that we can remove the excess water in the field to make the land. This was the before and after things we did. And then these are some of the structures of the artificial neural network we did, that we were for the hydrological modeling to predict of the surface runoff sedimentary. And then we have the data requirement I am mentioning, but you know all these things, I want to skip. And then we compare that back propagation neural model, general algorithm and Redel basis function. So we compared all these things, and then we did again the prediction type of thing for different type of drain spacings. And these are some of the data I want to skip. And also we published that in some good journal. And because there are in the era of AI, ML and other things, in the GIS also, ESRI, RGIS is very advanced. Then the open source QGIS, QGIS in the neural network also, we are having ANN neural networks professional. Then we are having MATLAB. In the MATLAB there is one module is there. आजकल तो बहुत ओपन सोर्स का सॉफ्टवेयर आ गया है, एंड डीप लर्निंग के लिए भी और पार्टिकल्स ऑफ एल्गोरिथम के लिए भी आ गया है, एंड these are the some of the structures, and then we use the that for the prediction. One of my students recently did a very exhaustive work on prediction of the climatic parameters and estimation of the water transpiration and actual water, because in agriculture we are very much concerned about estimation of the actual water transpiration. So that also we were doing with the using the AN and your subcommodity tools. This is some of the architecture in MATLAB we have did it, and then the different data. I am coming to some of the field activities using sensors. I told you that in the remote sensing analysis we are getting the signature. That signature what data we are getting need to be corroborated to the reality. To get that soil moisture content, we need to have that different TDR soil moisture sensors. There you can see we are at IRI. We are working on different experiments. We are collecting the data and matching with the reality. And these are the lysimeters which can give the actual transpiration. And these are the data we are getting. This is the decision support system we developed for prediction of the AET and IIT using different things. And then I want to skip it because these are some of the tools. And yes, we came up with a very holistic decision support system using all the background databases for water productivity estimation in rice and wheat cropping system for that northern India. So there also it is very useful for the farmers to know that which cultivar they will be using, what will be the water productivity scenarios for different regions, and then it is a very untold fact and fact with the farmers कि अगर ज्यादा पानी अप्लाई करेंगे तो ज्यादा यील्ड होगा. जनरली ऐसा नहीं होता है, एक टाइम है ऑप्टिमम होता है, अगर ज्यादा पानी अप्लाई करेंगे यील्ड फिर कम हो जाता है, because that the root zone environment they don't get proper erosion for their very bountiful growth. तो उसमें फार्मर का ये कंसर्न हमने through science we corroborated that if you apply more water then that will be giving less yield. So these are the different modules of the DSS. I don't want to speak much about this. And in the future challenges we are having the scarcity in water. So using your common estimation protocol that many of the faculties will be covering about the AET and water budgeting estimations. Then we can know that how much water we can get in an area and how we can go for our water accounting procedure. Then using that water, how we can grow our another crop production. And here the challenges are also the impact of the climate change, because the designs we are doing for the dams. What are the designs we are doing? They are the hydrologic design, hydraulic design, and the structural design. In the hydraulic design, we are going for the hydrological aspect. But due to changing climate, due to high intensity and long duration, everything is changing. जो structural design करेंगे, वो that will be in a dilapidated condition. वो टूट के बह जाएगा. So again, we have to reconsider about our design criteria. That is very important. So that we can do using our changing climate scenario databases and also the design procedures. And the quality of the soil and water resources are declining. So we have to be very much careful about applying the fertilizer, herbicides and other things so that we can have a sustainable agriculture. I mentioned about what is sustainable agriculture in the beginning. And then these are the variability maps you can have for the ground table variation. You can have for the rainfall variability. आप बहुत सारे मैप को जियो प्रोसेसिंग ऑपरेशन से ये करके आप you can identify this the area which requires immediate attention. This is the drought prone region which requires supplemental irrigation. This is the area where the irrigation water quality is very poor. You have to go for different cultivar to sustain the water quality. And also I think I'm just coming to. I'll finish within 5 minutes. So here you are having the soil moisture sensing systems that can tell you that when to irrigate. If the moisture content is going below the field capacity, at a certain level the plant can sustain. उसके बाद plant में stress आ जाएगा. So then we are using the soil moisture sensors. This is why we had collaboration with IIT. When I was at IIT, we had collaboration with IIT Mumbai. From IIT Mumbai, you could able to develop such sensors, and we are using, and our solar operated sensors are there. And also these are the access tubes we are putting. Only that sensor you have to put in the access. We have 100 locations. We have a data logger. You have to put that in different locations. Have all the information data logger, then we can see in the telemetric. We are having the telemetric systems now. We don't have to go to the location. Automatically the data will be coming to our laptop. These are the different activities we have done, but we are calibrating that using standard procedures. And now at IRI also we have developed a water measuring device, because in Odisha, the major problem in the command area is that we are not measuring the water. हम measure नहीं करेंगे तो कितना जरूरत है, कैसे करेंगे? Measuring is the prime aspect for water budget. So that devices, we are now collaborating government of Odisha and we are taking one location in near Fulnakra. So we will be having a pilot site demonstration of this. This is IoT enabled. So in the mobile, you can have the flow depth, the velocity of water, and Q is equal to A into G, the weighted area and velocity. So discharge also you can get कि अगर farmer उसका आधा घंटा चला रहा है, तो how much total water is going to the field? That also can come in the mobile. So this is IoT enabled. And then these are some of the experiments. Then digital support system for the commodity management, and also the laser leveling protocols for the leveling, and for wetland cultivation. So these are just I'm passing it. There are so many things because I could able to get. So now I can conclude that the my topic was use of geospatial tools. So I mean to say that there is no limit of application of the GIS and remote sensing and AI/ML tools. You can think of anything, but the limitation is that we have to ensure that we are playing with good quality data. We are doing the ground truthing. We are using the proper protocol. And one of my requests is that whenever you are using any model, please look into the manual that what type of equations they are using and whether that equation is basically fit for that area or not. Otherwise, that will be garbage in, garbage out, right? So the last slide I want to say that ego is equal to 1 by knowledge. So whenever you want to mix with people, try to learn, then your learning will be very fast. अगर आपके पास कोई knowledge है उसको share करते रहिए. Share करने से knowledge बढ़ता है. So that is what ego is equal to 1 by knowledge. And I'll end that with a story that in a jungle, एक जंगल में एक हाथी और एक monkey, both are very good friends. दोनों में बहुत अच्छा दोस्ती था. एक दिन क्या हुआ, दोनों के बीच में एक ईगो जनरेट हुआ. उन्होंने बोला मैं अच्छा काम करता हूँ और मैं अच्छा कंट्रीब्यूट करता हूँ, दोनों का अच्छा लिविंग के लिए आई एम कंट्रीब्यूटिंग मोर इन अ वेरी अमिकेबल लिविंग ऑफ बोथ ऑफ अस. हाथी को ऐसा लगा अरे मैं भी तो बहुत काम करता हूँ. तो दोनों के बीच झगड़ा हुआ. तो एक आउल था, वो देखा कि बोला कि मैं आप दोनों के बीच में झगड़ा का समाधान कर सकता हूँ. तो दोनों उसके पास गए. तो ओल ने बोला ये एक रिवर था. रिवर की द अदर बैंक ऑफ द रिवर देयर इज अ वेरी गुड ट्री having very good sweet mango tree था, अच्छा आम था. तो उन्होंने बोला आप अकेला करके जाओ, वो अच्छा वाला फ्रूट को तोड़ के मुझे दो. तो पहले क्या हुआ, the river was not that much wide but very high stream, बहुत जोर से माने बहुत तगड़ा करंट था वो रिवर में. तो मंकी कोशिश किया, जा नहीं पाया. बोला कि मैं तो जा नहीं पा रहा हूँ. हाथी ड्यू टू स्ट्रॉन्ग विंड he would able to cross the river, but when he went to the tree, उन्होंने बहुत कोशिश किया, ट्रंक लगाया फल तोड़ने के लिए, वो फल तोड़ नहीं पाया, वो भी वापस आ गया. तो उसके बाद they decided that we both will try something. तो हाथी ने बोला बंदर को कि मेरा पीठ के ऊपर चढ़ जाओ. तो आराम से जो when the monkey sat on his back, then he could able to cross the river. तो जाने के बाद monkey आराम से जाके जंप करके फल को तोड़ के फिर बोल को दे दिया. Then what is the moral of the story is that we cannot achieve success. हमारा गोल क्या है? हमारा गोल है to do some good research, like to have to have a good food, do some good research for the stakeholders of the country or anywhere for any global forum. हमारा गोल वही है. चाहे आप कैसे भी करो, अकेला तो नहीं कर पाएंगे. अगर ऐसे माहौल ऐसे एनवायरनमेंट आ जाता है कि अकेला हम नहीं कर पाते हैं, तो इसलिए ये स्टोरी का ही मोरल था कि हम लोग एकजुट होकर काम करेंगे तो we can have a very meaningful. Thank you very much. So with this, let me stop here. So I will be accepting some questions if you want.
Yeah, thank you, sir. Thank you so much for your generous time, sir. So if anyone have, yeah, we are having questions.
Hello sir, my name is Ashish Sarkar and it is a very good presentation. And I asked you showing the soil moisture sensor. So it's a low cost sensor.
Yes.
Actually.
Yes.
So are you sell this product or?
Yes. I'll just tell you that. Actually, in our institute or in the institute where I was working, we have developed some low cost sensors. And these sensors, you can see the FDR, TDR, they are around 2 lakhs and 3 lakh rupees. But the sensors, our institute manufacturing, they are around 10,000 rupees. So that sensors we are now giving to different parts of the country, like in Banaras and in Coimbatore, in Chalakot, in Kerala, we are giving that. So that is working very good. So we are developing that, calibrating that. So, but we are now going for patenting. Already we have submitted the patent. After the patent will be accepted, then we can commercialize. So we are waiting for the patent to be accepted. But if you want, you can send a mail to Director IIWM. Then we can try to give you one with our team. We can fabricate one for you if you are really interested to use that in your.
And another instruments that measure the volume of water,
Yes.
water ditches. So if I think it is a river channel, so that they are
No, the concept I developed is for an ultrasonic sensor. Ultrasonic sensor takes the depth, then the weighted area is there, and we measure the velocity using the two sensors at two places, then the distance. Velocity is equal to distance by time. We multiply Q is equal to AB. That is for the field channels I have developed, and already that is patented. Patent is submitted, patent is not accepted. But I can, but for the river, no. This is not work for the river. This is work for a small field channel. That is for the farmers field. क्योंकि हमारा एग्रीकल्चर इंस्टीट्यूट है ना, तो हम तो सेंट्रल वाटर कमीशन नहीं है, NIH नहीं है, और IIT का डिवीजन नहीं है, हमारा तो ICR का है. So we are working for the farmers. So इसलिए हमने field channel के लिए बनाया है.
Yes, and on another question is that you have applied so many models actually. So if my data is non-parametric, so if what should I do? Am I totally shift to machine learning models or any non-parametric regression models? So what is the interpretation of the difference between machine learning models and non-parametric regression models like KOLKATA?
Yeah. You see, that is a very good question. Now, I will take 2-3 minutes to answer this question. You know, the limitation for any data, if you are using the data should be independent of each other, they should be normally distributed. Then we can use a non-parametric, a parametric type of statistic we are using, but that is wrong. We have to use a non-parametric statistics. That is, we should not use that the student test or other thing. We have to go for Wilcoxon sign parameter rank, single parameter rank test, Wilcoxon sign pair double rank test. Then it is okay. So for that, what you have to do? Hello. Hello. Yes. So what you have to do? You have to initially go for a data screening technique. First, the data screening will be that you have to go for the removal of the outliers. Outliers can be removed in the geospatial by Horary mapping, or first quartile, second quartile, third quartile. You can remove the outliers. What are the outliers? Because in the time series analysis there are three things. One is the randomness, trend, and periodicity. आप अगर डाटा को प्लॉट करोगे, then we seeing that all the cluster data point is there. लेकिन कुछ डाटा पॉइंट ऊपर नीचे रहेगा. You have a lower limit, upper limit. उसको छोड़ के कुछ डाटा रहेगा. तो पहले वो डाटा को हटा दीजिए. I am talking about what you will be doing. You remove all the data. That means you have removed all the outliers. लेकिन outlier भी कुछ होता है due to faulty equipment. डाटा सही हो सकता है और इक्विपमेंट फॉल्टी हो सकते हैं, वो भी आपको फिजिकल ये करना पड़ेगा. मैं ऐसे नहीं बता सकता हूँ कि सब आउटलायर है. आउटलायर रिमूव करने के बाद you have to go for the normal to ensure that the data is normally distributed. That you know how you can do. If not normally distributed, you have to convert that data to normal distribution. You can go for a box cost transformation or linear transformation, any transformation you can take. After you take the transformation, then you can use that in a model. And another very important part of that your question is that what type of model will be using. So if your project cost or budget is very less, go for simple empirical model, black box model. क्योंकि जैसे हमने अगर कोई हार्ट सर्जरी कर रहा है डॉक्टर, तो उसका हार्ट बीट के साथ कोरिलेशन है जो कि एआई में दिखाता है. अगर हार्ट बीट कोई हेल्थ साइंस है जिसमें ह्यूमन का हेल्थ कंसर्न है, तो उसके लिए अगर अच्छा क्वालिटी का मॉडल नहीं होगा, थोड़ा एरर होगा तो भी मर जाएगा. बट इन नेचुरल रिसोर्सेज if there is 20% 30% error, that is not a problem. So you have to look into what type of activity you are doing, what is the budget you are having. If you are having a low budget and that is only for the natural resource management, go for close your eyes, go for the empirical model. And if you find that yes, I have to do something better, go for a conceptual model that is called a grey box model. Grey box model कैसे करेंगे आप? You have to add some concept to that. वो वाला अगर चाहिए तो मेरे को 1 घंटा लगेगा what is the concept you are adding to that बताने के लिए. So overall to answer your question is that you have to look into the system or the control volume for which you are working, and you have to select the model. You know, models are not the solution of anything I am telling you. वो एकेडमिशियन अपने आप को बचाने के लिए अच्छा पब्लिकेशन के लिए करते हैं। कल पहले मैं देख रहा था, जब मैं 20 साल पहले AIML में बहुत अच्छा पब्लिकेशन हो रहा था, तुरंत पब्लिकेशन करते थे बड़ा बड़ा जर्नल। अभी आप कोई भी जर्नल भेजिए, दे विल नॉट पब्लिश इट, दे आर टेलिंग दिस नॉट ए गुड वन। चाहे आप मैं अभी जो बता रहा हूँ तो रियलिटी बता रहा हूँ, आपको थोड़ा सा बुरा लग सकता है, बट इफ यू आर गोइंग टू पब्लिश इन डीप लर्निंग एल्गोरिथम, सपोर्ट वेक्टर मशीन, पार्टिकल्स ऑफ एल्गोरिथम, आप कोई जर्नल जल्दी उसको एक्सेप्ट नहीं करेगा unless until you have developed a very good protocol, unless until you have added some concept to that, make it from black box to gray box to white box, then only they are, because these are all black box models. तो मॉडल यूज करने के लिए कोई मजा नहीं है, only thing is the reality. क्योंकि रियलिटी में हम नहीं, रियलिटी में कंटिन्यूअस डाटा कलेक्शन, देयर इज नो सब्स्टिट्यूट ऑफ कंटिन्यूअस डाटा कलेक्शन, वो सबसे बढ़िया है, लेकिन हम कर नहीं सकते। क्यों? हमारा कोई प्रोजेक्ट 3 साल का आता है, कोई प्रोजेक्ट 5 साल का आता है, कोई इक्विपमेंट लगाता है, इक्विपमेंट खराब हो जाता है। If we can have a long term experiment to generate the data, उससे बढ़िया कोई नहीं है, मॉडल नहीं लगाओ। लेकिन जैसे आप देखेंगे कनाडा में, मेरा एक्सपीरियंस है जी, अगर कोई फ्लोरिंग होगा या बारिश होगा, क्या होगा, सो दे हैव ए वेरी गुड प्रेडिक्शन सिस्टम। हम अगर बाहर जाते हैं, अगर देखते हैं कि बड़ा बड़ा कोई गाड़ी आ गया, कोई सॉल्ट बैग लेके, वो क्या करते हैं ना, दे पुट द सॉल्ट बैग ऑन द रोड, जो कि जो हार्ड पैन हो जाता है, जिसमें गाड़ी पर टर्न करके एक्सीडेंट हो जाता है, that will melt that ice on the road. So when we see that, we came back to our apartment. That means their prediction system was so good. But now our IMD have come up with a very good prediction system. They are predicting the things very nicely. So gone are the days when we are using around 80 parameters to model the behavior. Now we are finding out the doing the parametric analysis and the data redundancy. Using the sensitivity analysis, there is one tool, you know, that is called MARS, multivariate adaptive regression splines. So I request you to use that MARS. MARS can tell you that what are the sensitive parameters or parameters having relative importance which you can use in model. जैसे आपके पास इनपुट 15 डाटा है, 15 डाटा आपको जरूरत नहीं है, आपको 15 में से 4-5 डाटा जरूरत है, वो कैसे टेस्ट करोगे आप? That you can do using MARS. 15 में ऐसा कुछ डाटा हो सकता है जो कि 30% इंपोर्टेंट है, कोई 20% इंपोर्टेंट है, तो आप जो इंपोर्टेंट है उसी को आप ले लीजिए, दूसरे को छोड़ दीजिए, then only your model prediction accuracy will better. So in totality, while choosing a model is not the solution I'm telling you. You should have a continuous data collection. Then all this pre-screening of the data is required before putting the data into model. Could you able to get something from my answer?
Okay, thank you, sir. Anyone having any more queries?
Yeah, either.
Yeah.
One of the side effects of irrigation is these salinization of soils. So using remote sensing, do we have techniques where the salinity of soil can also be detected?
Yes.
Extend the same question to water also, whether variations in salinity in water can also be detected using remote sensing.
Yeah, it's a good question. I told you that in some areas, this is the inherent capacity of the parent rock material. Due to vertical upward seepage, the salinity come out to the surface. It is not that everywhere you irrigate the salt will be there. It depends on the parent rock material, which is having inherent salt in the soil. If you irrigate, then there will be vertical upward seepage, that is the capillary rise. During the capillary rise, the salt in the bottom, they come to the surface. So yes, there are techniques of the NDVI and NDSI and other things, normalized different salinity index being developed from the remote sensing data. We have tested that for the agroclimate region 6, encompassing Haryana, Punjab and other regions, that is being tested. And also, yes, what is the another question? Yes, we can do in remote sensing.
In water, salinity of water.
Oh, salinity of water, no, it is not possible. It is not possible. Like the groundwater table depth also we cannot do using remote sensing. लोग बोलते हैं लेकिन होता नहीं है. There is called hyperspectral remote sensing. In the hyperspectral, they have to use a ASD, that is called analytical spectral device, that is around 40 lakhs rupees. So एक analytical spectral device का आप रखेंगे, उसका डाटा लेके आप उसको AI में लिंक करेंगे, they will be linking that with the remote the satellite data. And that also in India, we don't have any Hyperion sensor to work on the hyperspectral range of the remote sensing. इसीलिए थोड़ा अभी ठीक सही नहीं है. अगर लोग करते हैं ग्राउंड वाटर का, लेकिन एक्यूरेसी नहीं आएगा. वो बताएंगे इधर ग्राउंड वाटर है, पानी नहीं होगा. उससे बढ़िया होगा जो आपका वाटरमैन होता है. वाटरमैन केरला में होता है, वो एक रॉड है, उसको डिवाइन रॉड बोलते हैं. रॉड लेके जाएगा, रॉड जब ऐसे हो जाएगा तो वो बोलेगा इधर पानी है. दैट आल्सो वर्क्स. एंड कुछ वो एक आदमी है जो कि डिवाइन पावर है, स्पिरिचुअल पावर है, वो चलेगा जहां पे उसका पेट में दर्द होगा, वो बोलेगा इधर पानी है, और कोई नारियल लेके जाएगा, नारियल थोड़ा मुड़ जाएगा. So there are certain heuristics and other some premonitions are there. So that is working better than this remote sensing technology. Okay, any other questions? Okay, thank you very much for giving me an opportunity to interact with you.
Thank you so much, sir. So I would like Vishwajit sir to come and felicitate sir.
Thank you very much. Thank you.
Hello. So we must thank Professor Sarangi for his enlightening talk. So it's a great opportunity. He came over here to our institute to deliver such a talk and give a lot of ideas about his area of research and his work. Thank you very much, sir.
Volunteer.
ये सर की गाड़ी में रख के आना
अच्छा,